Alright, a supplier of clothing material looks for flaws before selling the material to customers. Fair enough. Number of flaws follows a Poisson distribution with a mean of 1.7 flaws per metre. So find the probability there are exactly 3 flaws. So A, this is a Poisson distribution, and it's a specific value, so probability distribution, and we've got how many flaws am I expecting to find? Oh, we've got exactly 3 flaws. So we're going to find 3 flaws where my expected value is only 1.7. It's only 1 metre of material, so this one's pretty straightforward. Calculators out. Menu, stat, distribution across Poisson. One specific value. It's a variable. I want to know the probability of getting exactly 1 flaw. No, exactly 3 flaws. What am I saying? It's 1 metre, that's what I was saying. When the expected number is 1.7. Not too hard. 0.1496. 0.1496. Seems about right, doesn't it? If you're expecting 1.7, yeah, there's a chance you'll get up to 3. Not a big chance. Seems about right. What about part B? Determine the probability that there is at least 1 flaw. Helps me get my pen roughly in the right place. At least 1 flaw in 2 metres of material. So now we want Poisson CD because it's at least. So it's a cumulative one, at least 1. So 0 or 1. No, at least 1 flaw means 1 or more. What am I saying? Probability at least 1 flaw. That would be the same as 1 minus the probability there are no flaws. 0 flaws. And in this case, we've got 2 metres of material, so my expected value has changed, hasn't it? So I'm going to have x equals 0. My expected value is going to be 1.7 times 2. 1.7 times 2, which is, of course, 3.4. That's the expected number of flaws in 2 metres of material. Let's see how we went with this one. So, exit out, distribution, cross, it's a Poisson distribution, at least 1. So we're going to do 1 minus probability of 0, so I can work out the probability of 0. 0 flaws when the expected number is actually 2 times 1.7, which is 3.4. Calculate that one, 0.034. 334. .0334. But of course, it asks us for the probability of at least 1. That's the probability of 0. So the answer to the question, probability of at least 1 flaw. Remember we had it's 1 minus 0.334. 0.334. We've done that twice, which is going to give us what? 0.9666. There we go. All right, now on with the next part. So probably going to have some flaws at 0, 3, 3, and 4 because it rounded up. Very good. Find the modal value of this Poisson distribution. Now, it hasn't really said whether it's for 1, 2, or whatever, but it would be the easiest way. So the modal value, of course, is the one that has the highest probability of occurring. So do they mean for 2 metres or do they mean for 1 metre? Not very clear. Let's assume they mean for 1 metre. So here we're going to calculate where our expected value is 1.7. So straight away you know either 1 or 2 are going to be one of those two numbers will be the mode because they're the two closest to that expected value. Because it's not a uniform distribution or a symmetric distribution, we can't be sure. So 0.18, that was for 0. For a probability of 1, we calculate that, 0.31. And a probability of 2, it's closer to 1.7. Does that mean that it's going to have a higher probability? 0.26. No, it doesn't. So just because there's 1 is still going to be more common because it's got to get above 1.7 it gets 2, and it gets harder to get more floors as you go along. So that one was 0.26. This one here, just refresh your memory, 0.31. There you have it. That one's going to be more likely. We've lost our screen there. If I turn it off and turn it on again, it'll probably pop up. We'll see if we can get that to work. And there you go. I've got it to work. Luckily, don't like having to rewrite everything once I've already done it. So the probability of having 0 floors, I think if I recall, was about 0.18. The probability of having 1 floor was 0.31. And the probability of having 2 floors, 0.26. Now, I'm trying to remember those numbers. I could be right, could be wrong. What's the other way we can do these? Just very quickly. Remember, we can put in our 0, 1, 2, 3, 4, 5, etc. And now we can go to our distributions. Poisson distribution. I want to know the specific value. Let's say it's a list, and I've got my list in list 1. And then we can see those values 0.18, 0.31, 0.26, 0.14, 0.06, etc. There you have it. So you can use your calculator, use your brain, use the formula if you want. Either way, get to the right answer. Catch you in the next one. 2 to go on the Poisson distribution.